Okay, Assalamualaikum warahmatullahi wabarakatuh. So we meet again today for PST371 Plastic Fabrication Chapter 7. We will cover on thermoforming process. Okay, roughly for thermoforming process, we will cover I think 7 techniques of thermoforming. Okay, I hope you can gain as much as information from this lecture. So we start from with the learning outcome. Firstly, for this chapter, by the end of this chapter, you should be able to identify all types of thermoforming techniques, to describe all types of thermoforming techniques, to compare various thermoforming. This is very, very important and very common question for thermoforming chapter, which is to make a comparison, and finally to suggest the plastic material used for various thermoforming techniques. Okay, what is thermoforming? Thermoforming is a process used to shape thermoplastic sheet into a discrete part. Of course, in this code PST371, basically you will learn how to converting a thermoplastic material to a desired parts or the final product. But uniquely for thermoforming, it is specifically shaping a thermoplastic sheets. So what I want to highlight here, this is the only technique that uses the thermoplastic sheets to converting into a final parts. Okay, the basic principle for thermoforming is start with the heats of thermoplastic sheet until it's softened. So in this technique, it is actually not turned into a molten state, but it's until it's softened enough, and then you force the hot and pliable material against the contour of mold by using either mechanical, air or vacuum pressure. This is the different techniques that we will cover in this thermoforming, which is either you use the mechanical technique, air or vacuum pressure. Later on we will go through what types of thermoforming that we have. And finally, helps again mold and allow to cool and plastic retain its shapes. So it is very simple process of thermoforming by shaping a thermoplastic sheets into a desired shapes. Okay, basically this is the illustration. The thermoplastic sheet, you heat up using a heater. The plastic sheet will be start to soften. When it's softened, you will put into desired shapes of mold, and you allow it to solidify, and finally you remove and trim the parts. So this is the illustrations of components, the final products of thermoforming using a thermoforming technique. Basically, this thermoforming used for either for display packaging, or either to rearrange a small components. Either it can be either electronic components, either stationary components, food. Okay, usually apa yang awak akan nampak dekat sini adalah kalau awak nampak box of chocolates, so there is small cases that help that chocolates from agglomerate to each other. Okay, nampak macam-macam awak bagi gift chocolate box tu kan, itu dia guna thermoforming. Ataupun awak tengok crates of egg, okay, tray telur tu is made from thermoforming techniques. Bukan yang kertas, yang plastik punya. Ada sandwich pack, and usually these types of thermoforming being used for packaging. Okay, either it can be a clear or opaque material, and most industry use for packaging, but some high-end industry they might use for automotive parts, okay, even or use for engineering parts. Later on we go through what types of technique that are capable of using a high-end or high mechanical properties of product using a thermoforming. Okay, thermoforming process is different from other plastic processing because the material is not melted. I mentioned earlier, it's not melted. Lower pressure are required for thermoform. Bila lower pressure, okay, less energy. When less energy, we use energy correlated with the cost of manufacturing. So kita boleh cakap this process is very cheap as compared to other types of process. Okay, the mold material is less sturdy material compared to other processing. Of course, that's why kebanyakan packaging ni kita akan guna pakai buang. Okay, as compared to other types of storage box. Sebab tu kita kata packaging ni pakai sekali dan buang. Sebab saya kalau macam kita guna untuk sandwich pack tu, kita pakai sekali dan kita buang lah. Okay. Rarely orang akan guna balik. Okay, usually for food industry kita akan pakai sekali saja. The disadvantage for these thermoformings generate greater amount of scraps. Cost of the sheets material is raised. Okay, of course, in order to produce a thermoforming, to use a thermoforming technique, you use slightly bigger size of polymeric material. Later we go through this one, why we need bigger. So bigger size, we produce a greater amount of scrap. Okay, bahagian yang kita tak nak ni kita akan buang, kita akan trim. Ni lah scrap dia kata. And then cost of the sheets material is raised because separated sheet forming step. Okay, of course, previously any types of fabrication that I cover use either raw material, can be either in pellets, what we call that, powder, flakes, and then granule and etc. But for thermoforming, it is limited to a sheets material. In order to produce a thermoforming product, you need a sheets material. So you need to convert your raw material into a sheet forms. Okay, dalam bentuk sekeping. So sheeting process is additional costs. Okay, so awak perlukan cost yang lebih untuk converting the raw material into a sheets. And then limited design, which is part with sharp bend and corner are difficult to be produced. Okay, there's some limitation, of course, with sharp design. The parts is much more difficult to be ejected after more what we call that, the plastic sheets are solidified. Okay, and then the process result in internal stress. Of course, thermoforming related with high stress of the material. Okay, as compared to other types of technique, although they also have a stress of the polymeric material, however, for thermoforming have a greater internal stress. Okay, this is some of the illustrations of the product using a thermoforming technique. Just now I mentioned about the gift pack. Okay, kalau tengok kat sini kita akan tengok macam bekas coklat. Okay, orang susun coklat dalam ni kan. And then communication packaging usually for electronic devices, so that you there is some separated component or spare parts that you can use to replace the communication packagings. Okay, and then also the high-end product such as the automobile inner decoration packaging. That's why I said that the automotive part also use the thermoforming. And then we have a specific different packaging. This one for agriculturals. Okay, macam orang nak buat pembenihan pokok tu sendiri, and then dia akan bungkus lah, dia akan separated untuk ni. Okay, wait ya. Okay, air pressure and plug acid forming of the softened sheets invariably automated and faster cycle times. Only thermoplastic sheet can be processed by this method. The largest application is for food packaging, of course. For thermoforming, usually I would say almost 70 to 80% of thermoforming industry used for food packaging. Other industry include the toiletries, pharmaceuticals, and electronics. Okay, food-related applications such as meat tray, microwave, and deep freeze container, ice cream, and margarine, etc. Manufacturing of collation tray, blister, packaging, and point of sale display tray. Ini pun saya cakap tadi untuk display because they helps that your final products visible, and at the same time protect from any damage. Okay. Next, summary of advantage and disadvantage of thermoforming process. Okay, advantage, basically low machining cost, as I mentioned earlier, low pressure requirement, low mold cost, low pressure requirement, large part easily formed, and fast mold cycle. But of course, there is some disadvantage for this thermoforming technique. High cost of raw material, which is in sheet forms, as I mentioned earlier. High scrap, okay. Limited part shapes, difficult parts or very delicate detail cannot be produced using a thermoforming. Only one size of part defined by mold, inherent wall thickness variation, and finally internal stress is very common. Although, as I mentioned just now, the stress, internal stress is very common with thermoplastic fabrication. However, for thermoforming is greater in internal stresses. Okay, thermoforming process. This is I mentioned on the first slide. We will cover different techniques of forming process. Basically, in this chapter, we will cover 7 techniques of thermoforming. Although when you go to the industry, you might find other than this listed thermoforming, but they actually what we call that derive from this type of thermoforming, or either combination 2 or 3 techniques of this thermoforming process. So the first one is fundamental vacuum forming. Second one is pressure forming, drape forming, plug assist, reverse draw, free forming, and finally the mesh die forming. And for your information, in our lab, we have a fundamental vacuum forming. I believe by now, we will already cover the vacuum formings for our Amali. Okay. And then we go through the first technique, which is the fundamental vacuum forming. Okay, the term fundamental is used to emphasize that this is the simplest method of vacuum forming. So, when you go to industry, probably you will find another type of vacuum forming which is not the fundamental. Okay, might be the derived from the fundamental vacuum forming itself. Okay, some information, set point. Set point is the condition where the temperature, time and thickness, etc. at which the sheet begin to set inside the thermoforming oven. Okay, in any types of thermoforming techniques, you require a set point, which is the plastic sheet start to soften and will tend to set. Dia macam apa? Dia turun ke bawah, dia berat kan, so jadi macam bubbles tu lah. Okay. Okay, and then wait. And then this is some illustration of the process for fundamental vacuum forming. Initially, you will have the material is clamped into a frame. So this is the clamping frame. So you need your sheets material to be clamped. Okay, of course, as I mentioned, the scraps leftover of the scrap because of this excessive material. Okay, kena ada lebihan sebab awak nak clamp kat tepi ni. Okay, the material is heated, begin to sag, the center of material move downward and seal against the mold. If you can see here, this is some of the illustration at the dotted line. This is the sag area. Okay, see this plastic start to sag, and then vacuum is applied to the backs of the mold, which is outside pressure of air push the plastic against the mold. Okay, so basically awak clamp material, awak heat sampai dia lembut, and then awak akan guna vacuum pump untuk sedut dia lah, okay, dapatkan bentuk of the cavity. So basically that's the techniques of the fundamental vacuum forming. The earliest method called simply vacuum forming when it was developed in 1950, in which the negative pressure is used to draw the preheated sheet into the mold cavity. And then a flat vacuum forming process, ini also in words lah, a flat plastic sheet is softened by heating. The softened sheet is placed over a concave mold cavity. A vacuum draw the sheets into cavity, and the plastic hardened to contact with the cold mold surface, and the part is removed and subsequently trimmed from the web. Okay. So this is the illustration. Earlier I said, okay, so you have a heater. As you clamp your plastic sheet, you introduce heat using a heater, and then as a plastic sheet start to soften, okay, it will start to sag, okay, and then you introduce the vacuum pressure, allow the plastic sheets to be sucked into a cavity, okay, and eventually when it takes shapes, you will eject the parts, you trim the final parts. Okay, the feature of vacuum thermoformed product. Of course, thermoforming will produce uneven wall thickness observed in this technique. As the sheet touch the mold, the thickness of the location become fixed. Further stretching occur at the area that have not yet touched the mold, typically at the corner. So this one is typo, the corner. Therefore, the thinnest area occur at the corner near the clamp. Okay, macam kita tahulah, sus keping ni bila kita heat up, bahagian yang bersentuhan dengan mold tu dulu dia akan fix, maksudnya dia tak akan stretch dah. Okay, bahagian tak bersentuhan dengan mold tu dia akan stretch until it reach desired shapes. Okay, so sebab tu dia punya thickness itu uneven lah, tak consistent, tak sama. So ada bahagian sangat nipis, ada bahagian sangat tebal. If you can take a look on the sandwich pack itself. Awak tengok kat bahagian yang sharp edges tu usually is very thin, okay, compared to the one on the flat surface. Okay. And then the second one, forming process is a pressure forming. What is pressure forming? Okay, slightly similar with the vacuum forming, but they use a pressure, which is in this case air pressure, positive air pressure from the top of the plastic sheet to force the material against the mold. So the technique is similar. Firstly, you clamp the plastic sheet, you heat up using a heater, and then as the plastic sheet start to sag, you introduce the air pressure, which is the external pressure, to blow this plastic sheet against the mold cavity so it can take the shapes of the cavity. Okay, this is some of the illustration. Okay, macam saya cakap tadi, you heat up until it sag, and then air pressure will be introduced, and the plastic sheets will take shapes of the cavity. The method, the plastic sheet is clamped, softened, the plastic sheet, air pressure is introduced, and the pressure applied quickly prevent the sheet from cooling. Okay, the advantage, mold cycle can be faster than fundamental vacuum forming. Okay, why it is faster? Usually, kalau awak tengok kita angkat barang kita tolak dengan kita tarik barang, tolak is much easier than daripada kita tarik, so that the cycle time will be reduced. This is significant lah. After all, the vacuum pressure, although the higher vacuum pressure is not comparable with the air pressure which is from the external sources. Okay, sheet can be formed at lower temperature because of the forcing pressure is high, greater dimensional control. Of course, because of the higher pressure as compared to vacuum forming. The third thermoforming technique is the drip forming. Use of a positive mold in vacuum thermoforming. Okay, this specifically guna untuk positive mold. Okay, dia tak boleh pakai negative mold. Okay, what is positive and negative later on saya akan tunjuk. Ataupun nama lain positive mold is a male mold. Okay. The technique is the heated plastic sheet is positioned above the concave plastic mold, and the clamp is lowered into position. Drip the sheets over the mold as vacuum force the sheet against the mold surface. So teknik ni sama juga. clamp plastic sheet, heat up until it's sack, okay, and then awak akan drip, awak akan wrap dia, tarik dia masuk ke mold yang positif tadi, ada bentuk tadi tu kan, and then you allow juga vacuum untuk remove any air and trap during the draping, and of course for better dimension stability. This is the illustration saya cakap tadi. So you clamp plastic sheet, you heat up until it sacks. When it sacks, okay, you move this plastic sheet against the what you call that, the positive mold. Okay, as the plastic sheet takes shapes, okay, you remove the part and trim. And then we have the plug assist forming. In this system, a plug is used to force the material into the mold. Okay, generally the plug will not push the material completely into the mold, and then the vacuum is applied to draw the material against the cavity wall. Instead of a vacuum, air pressure used to force the part against the wall. Okay, teknik dia macam ni. Awak ada plug, okay, this is the plug, okay, awak ada plastic sheet, so you panaskan plastic sheet tadi until it soften or sag, and then you push this plug. Okay, previously pressure forming awak guna air, tapi untuk plug assist you use this plug, you push against the cavity itself. Although the plug will not push until it touch the cavity, but you will use the vacuum pressure to push further the plastic sheet against the mold cavity. Okay, this is the technique lah. Okay, other than that, for plug assist we also have a pressure bubble plug assist vacuum forming, and plug assist pressure forming. Okay, tapi sama juga dia masih kita panggil plug assist forming. This is the derivations of the plug assist from other techniques of thermoforming. Okay, for plug assist thermoforming, we'll have a better wall thickness uniformity and obtained from vacuum and pressure forming, because you push the material first, stretch is more consistent, and then plugs can be made from the metal, wood or thermoset material. The plug should be 10% or 20% smaller in length and width than the female cavity. Okay, kalau plug tu kita panggil male, kalau yang cavity tu kita panggil female. Okay, and then the fifth technique is the reverse draw forming. It's used when very deep draw are needed. In this technique, the material is heated to sag point and then blown away from the mold. The purpose blowing is to thin the material in the centers of the sheets. The sheets of bubble is controlled by electric eye. When the bubble reach the correct size, the pressure is stopped and the plug press the material to the mold. The vacuum is activated through the mold to draw plastic against the mold wall. So basically ini teknik dia macam mana. Okay, so I think I go with this one. Okay, initially sama juga, you clamp the plastic sheets. Okay, you heat up the plastic sheet until it soften or it sag. And then you blow dia, tiup dia dengan angin lah kan, pressure with air pressure until it's bubble. So dia naik ke atas, dia akan naik ke atas sampai satu length ataupun the desired thickness, okay, the electric eye to detect. Okay, so dia akan stop. Okay, dia tak akan blow lagi dah, dia akan remain, and then the plug atau the mold itself raise, dia akan bergerak, dia akan bertemu dengan bubble awak tadi tu. Okay, and then it will introduce the vacuum to take shapes of the mold cavity ataupun plug tadi. Okay, so dia akan, kalau in term of this, kalau bentuk yang very delicate ataupun very depth, kita akan guna reverse draw forming. 6. Okay, we have a free forming. This is the simplest method of thermoforming. The free forming is done without a mold. Okay, very unique, dia tak ada mold langsung, especially those where the high optical quality is required. Touching the mold can result in undesirable changes in surface quality of the part. Okay, sebab tu kita nak ada mold. Okay, kita nak high optical quality. clarity and surface tu lah semua. And then complexity of shape of part is limited. Dia tak boleh ada bentuk yang very complex lah. Okay, very common shapes lah. Okay, often used for canopies. So macam mana dia sebenarnya? Dia macam ni je. Initially you clamp the plastic sheet, you heat up using a heater, and then as it sag, you introduce the air pressure. The air pressure ni dia akan tiup sampai electric eye detect berapa besar bubble tu. Okay, and then dibiarkan hold the position until it's solidified ataupun it's cool enough, then dia remove. Sebab tu dah digunakan untuk canopy. So teknik dia sebenarnya dia nak expand plastic sheet untuk bentuk yang dia nak je lah. Okay, so tak perlukan cavity. The final thermoforming is a mesh die forming. Some parts with very complicated shapes, okay, can best be formed in both plug and cavity mode. Okay, previously saya mention pasal plug assist forming. Okay, sebelum tu saya cerita pasal cavity mold. Okay, mesh die forming, they use both plug and cavity. Okay, untuk dapatkan bentuk yang very delicate, very complicated shapes. Okay, this mold must be meshed so that it can be fit together. Kalau plug assist tadi, dia punya plug tu tadi dia tak mengikut bentuk cavity, dia hanya stretch sedikit saja plastic sheet tadi. Yeah, tapi untuk mesh die, both of the shapes tu they can fit together. Dia mold kita tengok macam ni lah. Macam mana bentuk cavity dia. Okay, female mold ni macam tu lah bentuk male cavity dia. So sama juga, you akan heat up these plastic sheets. You heat up, okay, and then until it sags, and then you press using a male mold ni tadi ataupun plug ni tadi, male mold ni against the female mold, and you allow it solidify, and then you remove and trim. Okay, usually guna untuk automotive industry lah. Okay, yang very delicate details, and then very sturdy material, thick sheets, etc. Okay, as general, okay, thermoforming machine, okay, not as complicated or costly as other thermoplastic processing machine that melt the plastic material. Okay, so awak takkan perlu panaskan dia high temperature untuk dia melt up. Awak hanya panaskan dia sampai dia lembut saja, nanti dia soft lah, nanti dia sags. The elements of the machine heating chamber or oven method for removing the material from the oven and locating is so that the sheets and the mold can be brought into airtight contact. Machine can be a single mold batch system or continuous highly automated machines. Okay. Here's the illustration for single station thermoforming. So dekat mana dia akan ada heating the sheets, kat situ juga ada clamping the sheets and then moving the sheets to mold into a proper relationship for forming a vacuum or a pressure system. So dekat sini lah. So heat up, so dia bergerak, dia pergi ke satu, dia clamp, and then sama ada dia akan guna plug untuk push the pressure or vacuum lah untuk dapatkan shapes of the desired part. Okay, the critical operation parameter, this is very important. In order to have a very minimal in defects of thermoforming products and very what we call the cost effective operations. Okay, the most important sheet's property is thickness. Okay, whereas the variation in thickness over the sheet should be kept under 5%. Okay, kalau buat satu teknik tu, awak tengok dia punya variation of thickness is above 5%, you might to consider using a different technique. Okay, kalau 5% tu dia dah banyak sebenarnya beza dia punya thickness lah. Okay, throughout the surface, maksudnya semua surface awak akan measure berapa persen beza dia. Okay, daripada the initial thickness. Okay, uniformity from sheet to sheet is desired so that the processing parameter can be kept constant. I.e., the melt index is one of the sheet has a lower melt index than another. The amount of heat to achieve the same formation will be higher than in the sheets with the lower melt index. So kalau pakai different types of plastic material, so parameter dia akan berubah juga. Okay, you need to know the melt index. Okay, other variable that might change the sheets to sheets are density, molecular orientation, etc. Okay, kalau kita tengok PE, polyethylene sebenarnya. Okay, Polyethylene ni ada banyak LDPE, LLDPE, HDPE, VLDPE. Okay, the density, the molecular orientation itself akan mempengaruhi the final product that you produce. Either the opacity, either the thickness, either the defect they may produce during the process, etc. The critical operation parameters, okay. First one is speeds of vacuum application. Kalau guna vacuum lah, vacuum should be applied as quickly as possible. So kita tak nak akan plastic sheets to start to soften. Start to cool masa awak vacuum dia. Temperature of the mold is normally at room temperature or temperature below solidification point of the plastic. Size of the bubble is very important in order to have consistency in thickness, okay. And then the plug size, okay. Plug size juga mempengaruhi stretching rate ataupun stress of the plastic sheet itself. Male and female mold, ni saya kata tadi, female mold and mold in which a part is pressed into a cavity. Male and female mold are the only two fundamental types of forms, but they yield significant different finished parts. I think you go through this male and female mold, what are the different. Later on, I might do some discussion on this, which one is the best for what type of product, okay. Go through this male and female mold. For troubleshooting, okay, usually the problem that occur during the thermoforming, the first one is uneven shapes. This is very common. Okay, the cause is uneven heating temperature and clamping frame not hot. The solution is there. And then blister or bubbles, usually because of the heating too rapid and then uneven heating and excessive moisture. Some of the plastic material pick up moisture, so you need to preheat maybe or store the plastic sheets in an environment which is they can't pick up any moisture. And then poor detail and incomplete forming. This is very common in thermoforming techniques. Okay, usually we discuss these types of defects. Okay. Too much sag during sheets when forming, part sticking to mold, part warpage, surface marking, uneven edges, raised corner and cracking in corner. Okay, I think that's all from for this chapter. I hope to see you during the discussion so that we can elaborate more on this chapter thermoforming. By then, Assalamualaikum warahmatullahi wabarakatuh and thank you.